Hello everyone. It's so amazing having you once again on this wonderful learning platform. I'm sure you're doing very well. Today, we are going to be having Basic Science and Technology, Science, BSc Science, and in BSc Science class, we'll be talking about energy. The second part of the topic we started last week. Last week, if you remember very well, we started doing energy, and this is the second part of it, the part 2 of the energy. Remember I told you last week when I was teaching in the class that I will come back this week and I'll tell you more about energy, because energy is a very wide topic. It has to do with a lot of things. Quite a lot of things needs energy. I told you before that energy is the what? We can define energy for me now. What is energy? Energy is the ability to do work. Good. All the effort you put together to do it, in everything you do around you requires energy. You want to carry a pot, you want to carry a bucket, you want to push something, anything you do around the house requires energy. Taking the spoon into your mouth requires energy. Everything around you needs energy. Now, I'm Olayinka Modupe, and I'll be taking you along into this class. At the end of this class, I want you to be able to list out all the forms of energy for me. All of them, you should be able to list them out, and then you should be able to explain all the forms of energy, because I'll be explaining all of them for you. So please pay attention to the class. Last week, that's the review. Let's quickly review last week's work. We talked about energy. So what is energy? Remember I asked you the other time, energy is a what? Okay, good. Now what are the types of energy that we have? I gave you two types of energy, two basic types of energy. They are what? Potential and kinetic energy. Now each of those energy have their forms. We talked about the forms of energy under potential, and we talked about some under kinetic energy. So who can remind me those of them under kinetic and those under potential? Can you just get one or two? Okay, now good. We'll be doing more of those stuff, more of those things today. I will be looking at all those forms one after the other, and then you'll be able to, when you see any form of energy in the house, you'll be able to say, wow, this is an elastic energy. When you see this, you say, oh wow, this is chemical energy. When you see the other one, you say, no, this is light energy. When you see another one, you know, oh, this is thermal energy. You'll be able to single out each of the energies as they operate. You know what, this is mechanical energy at work. You know what, this is gravitational energy. No, this is gravitational energy. You'll be able to differentiate all the energies even after this class. So I want you to pay very good attention, because this topic is very, very interesting. Even me, I learned a lot while I was preparing the slide, because there are some things I never knew that were actually, and when I was seeing them, I said, wow, I was actually learning, I was actually teaching myself even in the class. Good. So I want you to pay attention to this class, because we'll be learning quite a lot of things into this class. Now, what's the two forms of energy we have is potential and kinetic. Now, let's start with potential energy. This is energy possessed by a body by virtue of its position relative to other. The position of the body of that object, stress within itself, electric charge, and other factors. We have the forms. There are 4 of them. Like I told you last week, under potential energy, we have 4. So those 4 forms of energy under potential energy are what we want to begin to look at one after the other today. So please, I've put pictures in all the energies, so that by the time you see a particular picture, the picture will buttress what I am trying to explain to you. So let's go to the next slide, which is chemical energy. You can see the picture of a chemical energy at work here. That's a matchstick bringing out the light there. You may be looking at it. It's also, like I told you in the last class, and I'm still going to be telling you today, each form of energy can be converted to another. Now, this is chemical energy here. Chemical energy is energy stored in the bond of chemical compound like atoms and molecules. Chemical energy can spark up fire. That's why you see it there. You can see it in battery. Yes, you can see it in atomic bomb. You can see it in different things. They can spark up fire at any time. That's why you see fire there. It's chemical energy that is at work. This energy is released when a chemical reaction takes place. Usually, once chemical energy has been released from a substance, that substance is transformed into a completely new substance. Now we can see example. Coal. How many of you know coal? Yes, charcoal is an example of chemical energy, because it can actually be transformed into fire. Then we have wood. Wood is also an example of chemical energy, can be transformed into fire. We have petroleum, we have battery, we have etc. food. There are things that can be transformed into fire. They can be transformed into energy. They can be transformed into a new substance. That's chemical energy. Now let's go to neutral energy. Neutral energy, just as it sounds, there are parts of our life that aren't big pulses, but they aren't negative either. They are not negative and they are not positive. You know, we call it neutral. When you say something is neutral, it's neither positive or negative. It's just neutral. So that's what we call neutral energy. You can see the picture of a neutral energy there. They are not negative and they are not positive. It's just neutral. That's why you see it there, neutral energy. Now we have gravitational energy. When you talk about gravitational energy, is energy a physical object with mass as in relation to another object, another massive object due to its gravity. Now, gravitational energy is dependent on the masses of two bodies, their distance apart, and the gravitational constants. Look at the picture I have here. It's talking about gravitational energy. Look at that picture of someone trying to get them from the top of that place, two of them. They are coming sliding down, from top to down. The energy that's at work there is called gravitational energy, bringing them from up to down, bringing them from the top of the staircase down to the floor. The energy that is at work there is a gravitational energy, or maybe a slope. When you're coming from, maybe in a car, or you're trekking, or you're moving down a slope. That energy that is at work at that time is gravitational energy. Example is bird in the air. The bird is flying up and down, up and down. Then it's the energy that is at work is gravitational energy. Or water held back by a dam. You see the water in a dam, up, inside that dam. The energy that's holding it back there is gravitational energy. Or book on a shelf. The books that are hanging there on the shelf. What is holding them back is gravitational energy. Or airplane in the sky. Airplane in the sky. The energy holding it in the sky is gravitational energy. I hope you understand that. Now we have elastic energy. Elastic energy. You can see the picture of that lady there trying to stretch her bow. And she wants to take a shoot. She's an archer. She's stretching her bow and she wants to take a shoot. She's an what? Archer. Now, what she's putting in place, the energy at work there is called what? Elastic energy. Because she's stretching that bow. Now, elastic energy occurs when objects are impermanently compressed, stretched, or generally deformed in any manner. You can see a lot of examples in materials around us in the house. It might be a clothing material. You can compress it and you can stretch it as well. You compress, you stretch, or you can get an elastic wire or an elastic rubber band, or even the one you put in your hand. If you have a rubber band in your hand now, it's elastic energy. You can compress it, you can stretch it, you can release it, it will go back to its normal size or position. You can stretch it again, it will drag. Or maybe your skirts. Mommy has put a rubber band on your skirts or your trousers, and then you wear it. The band there is you're using elastic for the band, and it can stretch and it can compress. Now we have an example, a coil spring of a wind-up clock. A coil spring of a wind-up clock, an archer stretch bow. This is an example of an archer stretch bow here. A twisted rubber band which powers a toy aeroplane. Okay, you know when you have a toy aeroplane, you draw the twisted rubber band, the aeroplane will go woo, it will come back. That's twisted rubber band that wires the aeroplane, or maybe a car, a toy aeroplane, a toy car, you wires it. That's elastic rubber band. Or a bouncy ball compressed at the moment it bounces off a brick wall. That is elastic. You see the bouncy ball, it will compress at the moment it hits the brick wall. And then the moment it comes back, it will stretch again. That's elastic energy. Now we have talked about the 4 types of potential energy. What are they? Can you mention them? Chemical, neutral, elastic, and the last one, gravitational energy. Now let's go to the second set of energy, which is kinetic energy. Under kinetic, we have 6 types of energy. This energy that is possessed by virtue of being in one position, it's not moving. In a position, the energy you use when you are in a position it's energy of a moving object, not in a position. Sorry, when an object is moving, the energy that you use when an object is moving is kinetic energy. Now the examples are thermal energy, mechanical energy, sound energy, light energy, magnetic energy, and electrical energy. So I'll be explaining them one after the other, just like I did for potential energy. Now let's go. Thermal energy or heat energy. Another name for, you can call it thermal energy or you call it heat energy. You call it what? Heat energy. They are saying the same thing. Thermal energy is the internal energy of an object due to the kinetic energy of its atoms and molecules. The atoms and molecules of a hotter object have greater kinetic energy than those of a colder one. So when you have something that is hot, it has more of kinetic energy than the ones that are cold. And the kinetic energy that is in that hot one is called thermal energy or heat energy. Heat energy is the result of the movement of tiny particles called atoms or molecules, ions, in solids, liquid and gases. Heat energy can be transferred from one object to other. I told you before that heat energy can be transferred. Example, the sun. That's the major heat energy that we have. The solar system, the sun, the solar system. Then the boiling a kettle. When you boil a kettle, you see the heat coming out of the kettle or a pot. That's heat energy. Then when the burner of a stove is very hot, you see, but when you see the heat coming out of that burner. Automobile fuels such as gasoline, hot engine of a race car or a school bus. When you open the engine of a race car or a school bus, you see the heat coming out of it. That's why sometimes when you enter the school bus, the place may be a bit hot. What is actually happening there is the heat energy is at work. Now let me have a picture here. That is fire. You can see the picture of that fire. That's heat energy. The moment you are close to it, you find out that you feel very uncomfortable because of the heat. Now, heat energy is at work. Even if there's no ventilation in the house, the windows are closed, the doors are closed, and everywhere there's no ceiling fan, there's no standing fan, the whole place will be heated up. That's heat energy at work. Then we go to chemical energy, mechanical energy. Mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Mechanical energy can either be kinetic or mechanical. Now we have an example. An example is a moving car. A moving car uses what? Mechanical energy. A moving car uses what? Mechanical energy. Now we have a barbell lifted high above the weightlifter's head. That's mechanical energy. Then pushing a door. You are transferring both potential and kinetic energy. You are trying to push the door or pushing a wheel, pushing something. You are making use of mechanical energy. Now you can see that guy over there trying to hit the nail, applying mechanical energy to it. Yes, carried up from the ground. This is the first step. Looked at it, saw the nail, the hammer on the floor. We looked at the hammer, picked the hammer up, and then hit it on the nail. That's mechanical energy at work. Now let's go to sound energy. Sound energy is the kind of energy that can be heard by humans. Sound energy is produced when an object vibrates. When an object vibrates, it causes movement in the air particle. Sound energy is a form of mechanical energy. I told you energy can be converted to different forms. One form of energy can be converted to another. So sound energy is a form of mechanical energy. You can see the sound. This is a drum. This is a guitar. This is a keyboard. And this they're all musical instruments producing sound. You can use your voice to produce sound. This is an example. That's my voice producing that sound. And you can use a whistle. That's a sound I'm also making while whistling. Then horn of vehicles. Yes, on the road you hear the vehicles horning. That's sound energy. Then musical instruments, just like I've showed you here, musical instruments can also be sound energy. Now we have light energy. Light energy is the kind of energy, it's the kind of kinetic energy with the ability to make types of lights visible to human eyes. Make lights visible to human eyes. Light is a form of electromagnetic radiation emitted by hot objects like lasers, bulb, and the sun. You can see bulb. You can see the sunlight. Yeah. So example is lighted burning candle, electric bulb, fire, star. Okay. So light energy can also be, fire is an example of heat energy I showed you before. It's also an example of light energy. Like I told you, energy can be converted from one form to another. So we have sunlight bulb, candle, fire, even from the star. From the star, you see that the light that comes from the star is light energy. Now we have magnetic energy. That's a magnet I have there. Magnet does what? It attracts. Magnet attracts energy. The energy of magnet stored in magnetic field is called magnetic energy. The energy of magnet stored in magnetic field is called magnetic energy. Magnetic energy is used to transfer the mechanical energy to electrical energy. Example, moving a magnet around a coil of wire. It is magnet, moving it close to a close wire, or moving a wire close to a magnet. That's what I meant by vice versa. Moving a magnet around a coil, or moving a coil around a magnet is an example of magnetic energy. The electrons in the wire creates an electrical current. So the magnet in the wire will create electrical current. So magnetic energy can be transformed to electrical current. Now, electrical energy. Electrical energy is a form of energy resulting from the flow of electric charge. Okay? It's a form of kinetic energy. The movement of charged particle through a wire or other medium is called current or electricity. You can see that plugged outlet. You can see it's bringing out energy, bringing out electrical energy. You can see it there. Bringing out electrical energy is an example of electrical. Every plugged outlet you have in your house, sockets and everything, they are examples of electrical energy. Now we have lightning, batteries, electric eels, power from a plugged outlet. It's an example of electrical energy. So hence, when you see a plug outlet, we know what that is using electrical energy. In conclusion, all the forms of energy has been explained. Each form of energy can be converted to another, and they are interrelated. They are what? Interrelated. Okay, I want to find out if you have been able to listen to the class. Now, list the two types of energy that we have. What are they? Potential and good. Now, mention the forms of each. Under potential, we have how many? Okay, under kinetic, we have how many? Okay, can you mention the ones under potential? Can you mention the ones under kinetic? Good. Now, thermal energy is also known as what? Heat energy. Very good, very good. I can see that you have listened to the class very well and you are good to go. Thank you very much. I'll be sending the class assignment as a class activity for you tomorrow. I want you to do very well and get all your scores. Take care of yourself. Bye.